All right, let me just highlight a couple of things before we start our final lesson today, which is over inverse trig derivatives. First is there's homework tonight, but I'll be checking this on Wednesday. And then you guys picked up a test review packet, but I'm not going to start that test review packet until Wednesday. Okay. But all the solutions are in the packets. I have videos for previous years of going through the different review sheets, review days. So if anyone wants to take the test early, they can start to prepare and working through the packet. Okay. But the test is scheduled for next Tuesday. Tomorrow is a remote day, but I will have a help session in the morning, so 9:30 to 10:30. I'll go over inverse trig derivatives. I'll go over related rates. And if you have any questions regarding other topics, I'll be available to answer any questions and just go over any review that you want to go over. Okay. Okay. Now, for those of you who want to do recovery from the previous test, okay, you just have to kind of plan out how you want to and when you want to do it. You can do it anytime this week or next week. So if you want to wait till next week to take that recovery test, just let me know and we can get scheduled for any time this week, next week, or tell me when you want to come any of the final 3 days during the half days. You're welcome to do that. Now, the trig unit test is next Tuesday. I will give a recovery opportunity for this test as well. So what I'm going to do is, as soon as you guys take that test, I'm going to flip through the tests and see, and I'll just grade those that I feel could be in danger of failing or lower than the 75. I'll grade those first. Okay. I'll grade those first and I will let you know by Tuesday night. I'll let you know either by putting it in the grade book or send you a text line. So that's my first priority. Okay, just to give priority to the students who may need a recovery. So that way you'll know by Tuesday night whether you got below a 75, and if you did, then you have the option to come in any of these 3 days to take the recovery test. You can look over your test first. Maybe you look over the test on Wednesday. You can pick up the test from me. Look over the test, ask me questions, do corrections, and then you can make up either Thursday or Friday. Okay. So those of you who looks like a test that's higher than 75, then I'll probably won't grade that test until later. Okay, but I want to give the priority to the students who may need a recovery since such a short turnaround time. Okay. But so yeah, just to let you know, we need everything made up and recovered by next Friday. Any questions? Okay. All right, so today's notes. Hey, page 21. Okay, so we have trig functions. We're not so concerned about the shape of the trig functions. It's good to know what sine and cosine looks like. But the idea is that none of the 6 trig functions is one-to-one. Okay, so what that means is if you look at, for instance, a sine graph, it's not one-to-one because it doesn't pass the horizontal line test. What does that mean? Horizontal line test means that if I draw a horizontal line for any trig function, I'm going to hit more than 1 point. It's not just going to be one. It's not going to hit the graph at just 1 point. it doesn't fail the vertical line test, but it fails the horizontal line test. What that means is that its inverse is not a function, okay? Because the graph will just continually go in an S shape and it'll fail the vertical line test. So we can't call the inverse a function unless we restrict the domain. So normally the inverse function would just be kind of like this S that kind of repeats back and forth, unless we restrict the domain and say that it starts and ends at a certain point where it will not fail the vertical line test. Okay, so just to let you know that we can only call inverse trig a function if we restrict the domain. Okay. Notation wise, it's important to know that inverse function can take on two forms. It can either look like this, sine with that -1 there, or arc sine. Okay, they mean the same thing. They're interchangeable. Just have to recognize that as interchangeable. Sometimes on the test, I may write it this way. I may write it this way. On the AP exam, you may see different presentations of it, but they mean the same thing. They just mean inverse. Okay, I want to make sure that we understand this. -1 doesn't mean that we're raising sine to the -1 first power. Okay, it's a special notation for inverse. It's not an algebraic expression that we can adjust and change. Okay, it's just a special notation. So if arc sine and sine are inverses of each other, okay, what that means is if I were to insert one into the other, they're just going to cancel each other out. So we discovered that with exponential functions and log functions, right? If I have natural log of e to the x, that should equal to x. If I insert exponential into the log, things will cancel out. If I insert the natural log into the exponential function, I'm also canceling out to be just bx. Okay, so same thing applies. If I do arc sine of x, I'm basically undoing one function for the other, and I'm just left with x. Okay, and if I have sine of arc sine of x, that also cancels out to be just x. So if I insert an inverse into the function, or I insert the function into its inverse, they're all going to have a way of undoing and canceling each other out. Okay, we have these last set of derivative rules that we have to be responsible for, that we have to memorize. It looks like a lot, but I do want to show you a couple of things, and I'll go into this a little bit deeper. You know how we have 6 trig derivatives, right? And they kind of are ordered in the same way: sine, tangent, secant, cosine, cotangent, cosecant, and I line them up the same way. Now they're just inverse functions, or arc trig functions. So arc sine, arc tangent, arc secant, arc cosine, arc cotangent, arc cosecant. The nice thing is a lot of that property will carry over, in the sense that the C functions will produce negative derivatives. So that's the nice carryover there. And also, what do you notice about the functions that are next to each other, the derivatives next to each other? They're the same, right? Arc tangent, arc cotangent are virtually the same. Arc secant, arc cosecant are virtually the same. These are just the negative versions of the ones to the left. So really, we don't have to worry about truly memorizing 3 of them. Okay, and I'll talk about a strategy that I use by comparing similarities and using the similarities to help me build my 3 derivative rules. Okay, if I know these 3, then I know I can figure out these 3 just by putting negatives next to these derivative rules. Okay, but first, let me do some trig review, and then we'll look at some derivative practice. So number 1 says find the tangent of arc cosine of √2/2. Now, when you see this notation, arc cosine of a ratio, that represents theta. Okay, this is just a very detailed information about theta. Okay, so basically, ultimately, we're trying to find tangent of theta. But using this information, we can figure out what are the details of that triangle. Okay, so well, I'm going to put a triangle in the first quadrant here, and we're just going to build this triangle. Okay, arc cosine of √2/2. Really, that's another way of saying theta is equal to arc cosine of √2/2. And really, if I rearrange that, that's another way of saying cosine of theta is equal to √2/2. Okay, And if I were to fill out this triangle here, cosine is SOHCAHTOA is adjacent over hypotenuse. So root 2 over 2. Pythagorean theorem, a squared plus b squared equals c squared. I can get this to show also root 2. So now that I have this triangle filled out and I have this theta information filled out as much as I can, now I'm just turning around and asking, what is tangent of theta? So what's tangent of theta? Opposite over adjacent, which is equal to what? Just 1. Yeah, that's it. Okay, let's try example 2. Sometimes we may recognize this as a special right triangle value, a unit circle value at power of 4. But even if it's not a special unit circle value, we can still gather information from the triangle. So here, example 2 says, find cosine of arc sine of 5 over 13. Okay. So in other words, we want to create a triangle where sine of theta is equal to 5 over 13. Okay, so how can I fill out this triangle here? Opposite of our hypotenuse, 5 over 13. Pythagorean theorem. So 169 minus 25 is 144. So I get 12. Okay. So that bracket is just to fill out my triangle. And once I have the triangle filled out, then I can do cosine of theta. Okay. What's cosine of theta? Yep. Adjacent over hypotenuse. Okay, next page. Let me do one more of these, but involving variables. And we're going to see this come into play later on when we are trying to clean up our derivative answer. So example 3, write the expression secant of arc tangent of 3x in algebraic form. First thing you want to do is build the triangle based off of that arc tangent of 3x. In other words, what would the triangle look like if tangent of theta is equal to 3x over 1, right? We don't see a denominator. We can always put a 1 in the denominator. How can I fill out the triangle if tangent of theta is 3x over 1? Opposites over adjacent. Okay, Pythagorean theorem can help me find my hypotenuse. A squared plus b squared equals c squared. Make sure you square both the 3 and the x. This becomes 1 plus 9x squared. So now that we have our triangle filled out, what is secant of theta? So secant is what? Hypotenuse over adjacent, right? So root 1 plus 9x squared over 1, or you can just leave it as root 1 plus 9x squared. Sorry. Okay, we can't get too creative here. We can't reduce this beyond what we have here. This is a plus sign, so if we leave these as separate, or if we leave this together, and the square root doesn't take away the 9 or the x squared. Okay. Let me backtrack a little bit. Let's go back to the rules. And I just want to use this space to kind of talk a little bit about my derivative rule here. Okay, so I briefly mentioned that I line the 6 derivative rules the same way that I do with my trig functions. It's just that now these are inverse trig. We still see a similar relationship on that right column. They all are just negative versions of the ones to the left. So I really just want to have us kind of talk about these 3 rules And if we can find the similarities, it can kind of help build these derivative rules a little bit easier, I think. So let's explore these rules a bit more. Okay, so first, let's look at these rules here. And can you name or can you list out a couple things that you see are similarities that is shared between all three rules? Okay, u prime in the numerator. Okay, and by the fact that you say numerator, I mean they're all involving fractions. Okay, but they all have the same numerator. Okay, what else is similar? Yeah, they all have 1. Okay, and they all have u squared. Okay, so if you look at these rules here, okay, the arctangent looks the cleanest, right? There's no square root, there's no minus, there's no absolute value. It feels the easiest one. So let's start here. Okay, we're going to build off of this arctangent, and if I can memorize this arctangent, I can arrive at these other two rules just by looking at, just by exploring some of the differences. Okay, but first, I know that all these rules have u prime in the numerator, so that's nice. Kind of get my similarities out of the way. Okay. Arctangent is the cleanest, easiest one. It has the plus sign. It has the 1 and the u squared without any radicals involved. So I like to start here. U prime over 1 plus u squared. Now, the arctangent is the simplest looking one. The most complicated looking one is what? It's that arcsecant, right? It's got that absolute value. It's got multiple u's. It's got square roots. So the most complex one has that absolute value of u sitting in front. It's got the square roots. But what I sometimes have trouble remembering is what order does the 1 and u squared go in? Because the arcsine and arcsecant, they kind of look similar. So what I do to help me remember is that the u squared comes first. And what helps me remember that is I know that for arcsecant, the u's are sitting next to each other. Right? The u's are next to each other. So if I can remind myself that the u's are next to each other, then that means I know that it's u squared minus 1. And then I'm going to turn over to arcsine because I know that arcsine is going to have a slightly different order in my square root. So instead of u squared minus 1, I'm going to flip that order. I'm going to call it 1 minus u squared. So that's how I go about remembering these three rules. And if I can remember these three rules, then the ones to the right, I just attach a negative in front. And that will be my arc cosine, arc cotangent, arc cosecant. Okay. All right, so we'll practice recalling these rules a little bit later over the course of this week. So let's look at some of these derivative problems here. I'm not going to do this implicit method. I think implicit method is good if we forget how to find it. If we forget the derivative rule and we're trying to rely on deriving it, that makes it nice. But the downside of implicit is it's very slow. And if you have a problem that has a product or quotient or chain rule built into it, it's not worth the time and effort to go through implicit. It just takes too long to build, even though you can rely on previous methods. Okay, so I'm going to jump directly into applying the derivative rules. Okay, it says find the derivative of arcsine of x. Okay, I want to match it up with my derivative rule. My rule says arcsine of u. So what's my u value? X. Okay. So let's follow what the rule says. The rule says u prime divided by the square root of 1 minus u squared. So what's u prime? 1, right? X's derivative is 1 over square root of 1 minus u squared. So 1 minus x squared. And that's it. That's my derivative. No need to rationalize the denominator. Okay. Example 5, we're just going to do the derivative rule here. So I'm going to write the derivative rule, the rule for arctangent. It's just u prime over 1 plus u squared. Okay, so I'm going to match the rules as I see it. All right, what's u prime? Just 4. Divided by 1 plus 4x squared. Now, is it right if I did this? Okay, what else needs to be squared? 4 as well. So make sure that you protect your u value with a parentheses, so you remind yourself that everything inside the parentheses gets squared. Okay, number 6. I have arcsecant rule. Do I need to do anything special with that too, like product rule? No, right? Now I could do product rule, but then it just feels like additional step. That 2 will go to 0. But really, I don't do product rule unless there's a separate variable. Okay, but here I'm just going to jump directly into my arcsecant rule. Okay. So arcsecant, the 2 is going to stay in front, and then it'll be u prime. So what's u prime going to be? Yeah, 3x squared becomes what? X divided by this absolute value of u times the square root of u squared minus 1. So u squared minus 1. Yes, my bad. Thank you. U squared. Okay, I'll do some cleanup here. The 2 and 6 can multiply out. Now I got the absolute value here. It's going to stay, but I can cancel something out outside and inside the absolute value. So I can take out a 12 and a 3. I could take out one of the x's. So I can still cancel out with something outside and inside the absolute value. I should need that absolute value to stay with the remaining expression. Okay, any questions with 6? Okay, number 7, we definitely have to involve arc cosine derivative. What else do you see? Product rule, yeah. The x is kind of hiding, but there's product rule here. X and arc cosine 2x, those are two distinctly separate terms. We got to go through product rule. Okay, f prime g plus f g prime. Okay, x becomes 1. Arc cosine stays. Back to f. And then g prime. So arc cosine is the same derivative rule as arc sine. We just have to put a negative in front, right? So negative u prime over square root of 1 minus u squared. So negative 2. Right? My u prime is 2x becomes 2. Do some cleanup here. Okay. Any questions with 7? Okay, take a look at number 8. Look at how this is set up here. What rule am I going to be involving here? Okay, it's not product. It's going to be more chain. The reason why it's not product is because it's not cosine of x times arctangent of x. It's cosine of arctangent of x, right? That arctangent is inside the cosine. So there's a little bit of a chain rule, not a big one, but there's still a chain rule because cosine of u becomes cosine of u times u prime, and that u prime is what that is where that chain rule gets activated. Or sorry, negative sine of u times u prime. So you got that outside portion, which is that cosine. You got that inside portion, which is that arctangent. And we're really taking turns with each derivative. But really, if you think of it as just negative sine u times u prime, then you kind of match the parts and just apply the rules. Okay, so first things first, let's apply the rule here. Negative sine of u times u prime. So u prime is where we're going to activate the derivative of arctangent of x. Arctangent of x, we go to our rule here, which is within that portion is u prime over 1 plus u squared. So u prime, x becomes 1 over 1 plus u squared, 1 plus x squared. Okay, so we have the derivative, but we're going to do some cleanup because we can actually do a little bit more in terms of getting our answer into algebraic form. And that's something that I'm going to be asking you to do. Okay, so getting it into algebraic form, the way we do that is we do the same thing that we did with example 3. Okay, we draw the triangle, we fill out our triangle, and we find the ratio based off the triangle. So we're going to do some cleanup there. Arctangent of x, what does that look like? Well, arctangent of x, same thing as tangent of theta, is equal to x over 1. So x over 1 is opposite over adjacent. Pythagorean theorem gets us to the hypotenuse, square root of 1 plus x squared. So now, what is the sign of this theta? Sine is what? Opposite over hypotenuse, right? So x over square root. The negative is going to hang out in front. So I'm using the triangle to get that trig to show back to an algebraic expression. And now I can merge this together. This is raised to the 1/2. This is raised to the first power. They both are the same base. If I multiply bases, I add exponents. So 1/2 plus 1 is 3/2. Any questions? Thank you. Okay, so for the remainder of the period, I just want us to practice more with these rules. So if we can turn to page 24, and we're just going to work through these derivative problems. Okay, page 24. The key is on page 26, but I'm going to have you guys try these problems, and then I could go over any that you guys have questions with, but want to see how you guys do. Okay, page 24. Okay, I have the derivative rules above, and the key is on page 26.
We have nobody goes with tense.
Yes, we do. Yeah. Mhm. Because the derivative of cosine of u is negative sine of u times. So we have to apply that rule first. It's kind of like outside, inside, right? You got my outside portion is changeable, so outside is cosine. Inside is. So I'm taking terms of this derivative. Cosine's derivative is negative sine of u, and inside derivative is if you find it. Yeah. If 44 feels messy, remember, if you divide a fraction, it's same thing as multiplying by the reciprocal of the denominator, right? So you do this 1/2 root x divided by 1 plus x, same thing as 1/2 root x times the reciprocal of 1/1 plus x. And that helps me see, oh, I can just put, they all basically share the same denominator, put it all together. Oh, the square root of this one here.
Yeah.
1/1/2 x to the negative 1/2 is same thing as 1/2x to the 1/2. The same thing as 1/2x. But if you left it as 2x to the 1/2, that's fine as well. You don't have to convert it back to right. Oh, I just arbitrarily did that. Okay, 46, hopefully we recognize that as product rule and go through product rule accordingly. And 47 is similar to the one that we just did. Chain rule, sine of u becomes cosine of u times u prime. The nice thing about this cosine or cosine of t, these are just inverse functions of each other. So we thought about how inverse functions cancel each other out. So really, you're just left with just a t there. And number 50, we have to bring back an old rule. Natural log of u is u prime over u. So that takes care of that first portion. If you leave your answer unsimplified, I'll be okay with it. So 450. Okay, any questions? Okay, last thing I want to do, page 27, I want us to take a first stab at seeing if we can recall these derivative rules, and I'll go through it again with you. Okay. So really, we talked about how you only have to worry about 3 of them here. Okay, we talked about how, let's start with the similarities, right? They're all involving fractions. They're all the numerator have what? 2 prime and they in the denominator, they all have what? 1 and u squared. The simplest looking one is that arctangent. It's just the 1 plus u squared. We know arcsine, arcsecant are the messiest ones. I'll go to the messiest one here, which is, I got that absolute value of u. I got the square roots. I have the u squared and the 1, but there's a minus sign in between. And I know that the u squared is going to come first because my reminder is my u's are next to each other. And if I know this pattern, I can use it to help me build my arcsine. I know my arcsine will look a little different, not as complicated looking as arcsecant, but I'm going to change the order here just to make a difference. So instead of u squared minus 1, I'll make it what? 1 minus u squared. Okay. And if you can know these 3, then you know arc cosine, cotangent, arc cosecant are just the exact replicas. Just put a negative in front. Okay, so cover that up and try again and see if you're able to arrive at these rules from scratch. Okay, try them. Okay, how do we do? Okay. Okay, so homework tonight, I'll send out a reminder tomorrow. Final homework assignment. I'll have a help session tomorrow, 9:30 to 10:30. Going over later rates, going over our trig and any other topic you want to go over. Okay. I'll report the team session as well. Get your phones. Yes, yeah, and I will record the team session. I'll put it under tomorrow's dates. I'll put a link there.